Hello everyone, hope you all are doing well. So in this video we'll discuss the last problem of Leetcode Weekly Contest 324. It's a hard level problem. The problem name is cycle length queries in a tree. So the problem statement says that you are given an integer n. There is a complete binary tree with 2 raised to n minus 1 nodes. The root of that tree is the node with value 1, and every node with a value val is in the range of this. And each one has obviously two children because it's a complete binary tree. So the left node has the value 2 into val, and the right node has value 2 into val plus 1. So something like this. So 1, then it will have 2 into 1 plus 1. Left will be this, right? Or sorry, the left will be 2 into val, so 2 into 1. The right will be 2 into val plus 1, 3. Then again this will be 2 into 2. This will be 2 into 2 plus 1, 5. This will be 3 into 2, 6. 3 into 2 plus 1, 7, and so on. So this is a complete binary tree. So it says that what are the values of each node. Okay, you are also given a 2D integer array queries of length m, where queries of I equals to ai comma bi. For each query, solve the following problem. Now what is that problem that we need to solve? We need to add an edge between the nodes with values ai and bi. Okay, find the length of the cycle in the graph, and then finally remove the added edge between the nodes with value ai and bi. Okay, so that means suppose someone says that add an edge between 4 and 2, so you add an edge here. Now find the length of the cycle. So what will be the length of the cycle? 1 2, right? 1 2. So the length will be 2 in this case, the cycle length. And after you have done this, remove the node that you just added. Remove the edge that you just added. Okay, this is what the problem says. Some points to note: a cycle is a path that starts and ends at the same node, and each edge in the path is visited only once. Okay, the length of the cycle is the number of edges visited in the cycle, right? Basic stuff. There could be multiple edges between two nodes in the tree after adding the edge of the query, right? So simple, as I showed you, right? Return an array answer of length m, where answer of I is the answer to the ith query. Okay, these are certain examples. So like, just see, this is a tree. Okay, this is a tree, and in this n equals to 3, and the first one is 5 and 3, meaning add an edge between 5 and 3. So just see here, an edge is added. Now what is the length of the cycle? The length will be 1 2 3 and 4. So you just see 4 is the answer. Now forget about this. Add an edge between 4 and 7. So you add an edge between 4 and 7. Now what is the length of the loop? 1 2 3 4 and 5. So 5 is the answer. Similarly, remove this one now. Add an edge between 2 and 3. You add this. What is the length of the loop or cycle? 1 2 3. 1 2 3. This is the answer, right? This is the second example. So in this, again, we have 3 nodes and we add an edge between 1 and 2. So what will be the length of the cycle? It will be 1 and 2. Simple. So this is what the problem is saying. These are the constraints. N can go up to 30. So we can have 2 raised to 30 minus 1 vals in the rest of the nodes. And the queries can go up to 10 raised to power 5. So this is the code. Let's first go into the explanation, and then we'll see what's the solution for this, right? Let's first go into the intuition. Okay, so suppose I have a graph, or sorry, a tree, something like this, right? 4 5 6 and 7. Now first thing to note here is, suppose, let me just change the color for clarity. Suppose I choose red. Yeah, so suppose I add an edge something like this. Okay, so just see, if I want to find the length of the cycle, what will be the path for it, right? What will be the path for it? From 5 I'll have to go to 2, right? From 2 I'll have to go to 1, then from 1 I'll have to come to 3, and then from 3 I'll again have to come to 5. Okay, this is the thing that I'll need to do. Okay, let's look into some other paths. Suppose I attach 4 and 7. Let me just change the color again just for clarity. Let's take blue. Okay, I add an edge here. Now what I need to do, I need to travel from 6 to 3, right? Then 3 to 7, and then this. So the length will be 3. So just see here what we are doing, whichever nodes you are connecting. So the basic stuff that you need to do is, in this case, from 6 I move to 3, and from 3 I did not move to 1 because there was already a path from 3 to 7, right? So what I mean to say here is these are the two nodes that were an edge was added between them, right? So, and this is the lowest common ancestor of these two nodes, right? What is the lowest common ancestor of two nodes? So suppose I have a tree like this, right? I have a tree like this. So suppose you need to find the lowest common ancestor. So what do? You move from here to the root node. Okay, you do this, and suppose this is the node, so you move from here to here as well. Now whichever is the first node which is common in both the paths, right? Whichever is the first node which is common in both the paths, like from here you move like this is the first node that is common in path of these two nodes, this node and this node. So that means this will be the lowest common ancestor. This is also a common ancestor, but this is not the lowest common ancestor. Lowest is when you move from root to bottom, which is the last level that has a common node, right? Which is an ancestor of this node and this node, right? This is the lowest common ancestor part. Okay, so once you are able to find this, the solution for this problem is very easy, right? What we will do is, let me just move to the previous color. Yeah, what we need to do is, so suppose whatever the values you have, irrespective of whatever is the value, right? Since again it's a complete binary tree, so if I am given this node and this node, so what I'll do, I will find the lowest common ancestor. I'll find the path. I move from here to here, then here to here, right? Length was 2, then I move from here to here, and this was attached. So the length is 4, 1, 2, 3, and 4. Okay, this will be my answer. One thing. Now comes the question, from a given node, how do I move to the parent node, right? That's the question. Now that is already given in the description that for a value x, your left child is 2 into x and right child is 2 into x plus 1. Or I could say, if you want to move to its parent, so you just divide by 2, you move here, right? How? Because this is 1, this is 2, this is 3, right? You divide it by 2, you move to 1. You divide it by 2, you move to 1. So let's take this value. This is 4, this is 5. Divided by 2, you move to 2. Divided by 2. Again you move to 2. What I mean to say is, you divide 2 raised to x or 2 raised to x plus 1 by 2, you get x itself. So you are able to move to the parent node, right? So these were the 2 points. One was how to find the path. So that is through LCA. And how do you find the LCA? So that is through this, right? So I have what I have done in the code is, once these things are clear, you just need to basically find the LCA, find the path and return it, right? So if I show you my code, then just see, this is the main function. These are the number of queries, this is the answer array, and a bunch of other things. Again, these 2 lines can be skipped. I was applying some other logic, hence I forgot to move this. You don't need to sort it. All I need to say is, you need to find the two nodes which are connected by an edge, right? And this will return your answer. Now come to the core function, find LCA length, right? Now once you come here, just see, I have node 1 and node 2. Okay, again this naming is pretty different. Why? Because I was applying another logic and it was accepted to that as well, but I found it to be a better solution, right? So once I completed, I thought let's try another solution, so that is why. Okay, now what I am doing, assume it to be node 1 and node 2, right? The two nodes that will be connected by an edge. So find the path, right? Find the path. So this is a function to find the path. Which path? So suppose you are at something like this, 1, 2, 3, 4, 5. Suppose you want to find the path of 5, right? I want to move to the root node from 5. So what you will do? You from 5 you will move to 2, then you will move to 1. So while n is greater than 0, add n into the path and divide it by 2. Simple. So add 5, then the new node to which you have moved is 2, then add this to the path, move to 1, and so on. Keep on moving till you move to 0. Okay, so obviously 0 will not be added, right? So this is the path. So what you do, you calculate the path of the current node to the root node. These are the 2 paths. Now simple, apply a brute force. Why I have applied a brute force here is, again, you can optimize it by doing a binary search. Why I have done this? Because the total number of levels can be up to 30 only. So 30 cross 30 is not gonna time out, right? So that is why. So now just see what I have done here. you get two paths, right? Let's do a dry run here. Suppose I want to connect 4 and 5. So what will be the path for 5? Path for 5 will be 5, 2 and 1. What will be the path for 4? It will be 4, 2 and 1, right? So what will be the LCA? What I said, the first node that is common in both of them, this is the LCA, right? This is the LCA. So what will be the length? If you see it diagrammatically, so 4 to 2, 2 to 1 and this attach it. So the length will be 3. So what I'll do here, what I have done, I have checked, I've checked each and every value. So P1, so this is the P1 array, this is the P2 array. Check the first value. Is it present in this array or not? No, it is not present. Check the second value. Is it present in the array? Yes, it is present. That means this is the first node that is common in both of them. So that is, this is the LCA. Now once you find it, what you will do? Simple stuff. What will be the length of the cycle? It will be the number of edges that you have seen here, the number of edges that you have seen here plus 1, right? So that means how many edges have you seen here? Just 5 to 2. So 5 to 2, 1 edge. How many edges you have seen here? 4 to 2, 1 edge, and just add plus 1 because you have added an extra edge here. So for this, what you will do? I plus j plus 1. I is the number of edges you have traversed in P1. J is the number of edges that you have traversed in P2, and plus 1 is the extra edge that you added, right? Finally return it. So obviously your answer will be here only, but again, since you need to add a default return statement, I've returned -1, right? So yeah, this is the stuff. This is the crux of the problem. I hope this was clear. Because again, to solve this problem, you need to familiar with a couple of concepts. One is LCA, and obviously the second one is how you move from a child node to a parent node. Now since it's a complete binary tree, it simplifies the problem. It simplifies the problem a lot, because obviously 2 raised to 30 minus 1 number of nodes, you're not going to build the tree, right? So you need to come up with a trick that how do we solve this problem. And you can see that the solution is pretty small, which you generally get in the other level 4 problems, right? So yeah, I hope you learned something new from this video. Do support it by giving up a thumbs up. Do subscribe to the channel. In case of any queries, do let me know. I'll revert on each one of them. Thank you. Take care. Bye bye.